Okay, welcome back, everybody. We had been looking at these demos that I put together for you to discuss the issue of what we're doing with the transceivers. And in the same way that a piece of plastic pipe can act as a substitution for garden hose, in the world of Wi-Fi communication, Ethernet or radio frequency transceivers can act as a substitute for copper wire. And the traditional use of these transceivers is to move data that's flowing down one set of copper wires across air to become data that's flowing down another set of copper wires. And we have a separate use that we're going to pick for these transceivers, because part of the fabrication parameters for these transceivers are that not only do they receive radio frequency energy, so when Ethernet transceiver S turns itself on and sends out radio frequency energy, Ethernet transceiver 1 has built into it the ability not only to listen to and unmodulate this radio frequency signal to get the data out of it, but they build into these Ethernet transceivers these 60 gigahertz Wi-Fi solid state integrated circuit transceivers. Built into them is also a circuit that measures power level. And it measures power level in an analog type fashion, where it doesn't just say power is here or power is not here. It says power is here and the power level is at a certain amount of so many units. We're going to pick a unit of 10. So with this Ethernet transceiver S is broadcasting radio frequency energy across air, and it runs into this Ethernet transceiver 1. This Ethernet transceiver 1 would say that the power level at this point is 10. This will become important later. Now, we have to bring out that human beings are not able to see all types of electromagnetic radiation. Human beings are able to see light, which is radio frequency radiation at a very high frequency, a very short wavelength. And we're very familiar with light because we perceive it and grow up with it and our eyes can see it. But human beings do not have an ability to see electromagnetic radiation in much lower frequencies like radio waves or microwaves. And so we do not spend our time perceiving radio frequency energy at these radio frequency, microwave, infrared wavelengths. And things happen with respect to electromagnetic radiation when this electromagnetic radiation is exposed to objects who have a size parameter close to or smaller than the wavelength of the radiation. And the radiation has certain behaviors that it exhibits with respect to its interaction with objects, and this radiation interaction between electromagnetic radiation and physically real objects, when these physically real objects are of a size that is near to or smaller than the wavelength of the electromagnetic radiation, that interaction if there was a way that you could show what it looks like to human beings, the behavior of it is counterintuitive to what human beings think might happen.